So, today what we will see is that the type of sensors which are mostly used in order to determine the attitude of the satellite. Sensors play a very important role in the satellite's life because the devices which will capture the health status of each and every subsystem of the satellite are the sensors. If there are no sensors, then we cannot determine how the satellite is behaving in the space. So, regularly we need to check the orientation of the satellite and the attitude of the satellite. If the direction of the antenna is not properly directing towards the surface of the earth, then we will have the problems in the communication link. So, in order to avoid those communication link problems, we need to always check the attitude of the satellite, whether it is in the correct direction or not. If it's not in the correct direction, then we need to correct the position of the satellite using some internal methods which we have on the satellite. And also, the radius of the satellite, the inclination of the satellite, and another important parameters we need to regularly check. If there are any changes in the radius or inclination, then we need to correct them. And to determine whether we have any changes in the radius or inclination or attitude, we need some sensors. And not only these sensors, each and every subsystem in the satellite, whether it is functioning properly or not, we can know only by checking whether using the sensors. Now, such sensors, some of the important sensors we need to see is that one of the sensor we have is gyroscope. A gyroscope measures the angular velocity of the satellite about its axis. Whether it is maintaining the exact angular velocity or not is checked by the gyroscope. And the principle of the gyroscope is on conservation of angular momentum. And the types of gyroscopic sensors we have is mechanical gyroscope, fiber optic gyroscope, ring laser gyroscope we have. And the axis of the satellite is always measured by the gyroscope. That means whether it is maintaining a proper level or not. So the satellite at what axis we have left it in this space, whether it is maintaining the same axis or not. It measures the rotational rates it measures. And so if there are any changes in the axis of rotation of the satellite, then it means that there may be change in the position of the antenna of the satellite also. So in this way, we can determine whether there is any change in the direct orientation of the satellite, and thus we can check whether the position of the antenna is accurately present or not. And if you see, this is one of the gyroscopic sensor, mechanical gyroscopic sensor. So we can check here the rotor, gimbal and gyroscopic frame. So if there is any change in the axis, then there will be change in the position of the gyroscopic frame and gimbal. And using that, we can determine whether we have any change in the position of the antenna of the satellite or not. And similarly, we have another type of sensors which we call it as magnetic torque sensors. So, a device that produces torque by interacting with magnetic field. So, because we need to check if there are any external forces acting on the satellite or not. And one of the external force which can act on the satellite is its magnetic field. If there is that magnetic field present there, and this magnetic field may cause the change in position of the antenna. And in order to check that, we have magnetic torque sensors. If there is force, and according to the amount of force which is present there, so that external force can act on the satellite, and the satellite's position may be changed, and maybe the antenna may be tilted or radius may be changed. So, in order to detect that, we can use the magnetic torque sensors. And the magnetic torque sensors are just like coils and rods. We know that when a magnetic coil, when a current is passing through a coil in the magnetic field, then certainly there will be deflection. And according to that deflection, we'll calculate what is the amount of electromagnetic energy present there. And if you know the force, according to the torque which is present there, we can identify how it will affect the position of the satellite. So we can see here a type of magnetometers on the satellite, and we have the star sensors. Now, why we require a star sensor means always we'll be checking the position of the antenna with respect to the star, and it produces the high accuracy attitude determination by observing the star patterns. And how this particular star sensors will be working means it will capture an image using the camera, and this image is compared with the images which are there in the database. And when we compare the images which are there in the database, if there is any change in the antenna, if there is any change in the photographs which is there in the database, as well as the image which is taken by the camera, and according to that change, it will identify the change in the position of the antenna which is present there. So in this way, a star sensor is asked. So a satellite need to be checked its position with respect to the other stars also. So we'll be checking, because in the space we cannot take other references. The references which we have is only the stars which are present in the space. So we'll have a star sensor which will capture the position of the antenna with respect to the star, and an image is captured, and we'll compare that image which is there in the database. If it matches with that, it means that it is in accurate position. If there are changes, it means that there is change in the position of the antenna, and it can be corrected in that way. So we can see here, so a sensor which is there here, it is taking a photograph here, and with respect to this photograph, we'll compare this image with the image which is there in the database. If there are any changes, then it means that there is change in the position of the antenna. And similarly, we have even the sun sensor also, and the purpose of the sun sensor is to check the position of the antenna only. So how we'll be checking means here, we use incident angles of the sun, and in order to determine the incident angles of the sun, we have the photodiodes, and these photodiodes will determine the angle of incidence, and according to the angle of incidence, we can identify the position of the sun. And if we identify the position of the sun, then we can rotate the solar panel in that way. And we can also check the attitude using the sun sensors also. So mostly it is used for rotating the solar panel in the direction of the sunlight. You can see here. So at the center there will be the incident angles. There are different incident angles which are considered here, and according to the differences in the incident angles of the sun, we'll identify the position of the sun with respect to the satellite. And after identifying the position of the sun with respect to the satellite, then we can rotate the solar panel so that direct sunlight is received by the solar panels. And another important type of sensors we have is that horizon sensors, earth sensors. So here what we do is, it measures the earth's horizon using infrared radiation to determine the nadir direction. So nadir direction means, so we have two directions. Suppose if we see the satellite from the Earth's surface, we call it as the zenith direction, and from satellite if we observe the Earth, the direction we call it as the nadir. So we'll measure the Earth horizon using infrared radiation to determine the nadir direction. And what is the working principle here is that it senses the IR difference between Earth and space background. And according to that, we'll identify the position of the Earth. So like this, we have different types of sensors.